A self-driving rover on Mars has already shattered every distance record set by earlier missions. This is Fascinating Frontiers, episode 156. Fascinating Frontiers has followed several threads across the past week. NASA and ESA have advanced multiple exploration efforts while Intel floated early concepts for orbital data centers. Those ideas sit alongside steady commercial launch activity and telescope observations that continue to refine what we know about nearby systems. NASA's newest Mars rover employs autonomous driving software that lets it cover more ground each day without constant commands from Earth. The system has already allowed the vehicle to surpass every prior rover's total distance traveled. Onboard navigation uses cameras and hazard detection algorithms to plot safe paths across rough terrain. Engineers report the rover continues to operate well beyond its original design goals. Remember, we covered robotic exploration yesterday. Today's news moves that forward because the Astronomy is now delivering record distances. This approach trades some risk for far greater daily progress across the Martian surface. From the practical payoff of autonomy on another world, we turn to a routine but reliable ride closer to home. A Falcon 9 lifted off from Vandenberg Space Force Base at 1635 UTC on August 8th, carrying 24 Starlink satellites. The mission marked another step in the ongoing West Coast launch cadence for the constellation. Deployment of the satellites was confirmed shortly after separation from the second stage. The flight used a previously flown booster that returned to a drone ship in the Pacific. Liftoff occurred at 9:35 a.m. Pacific Daylight Time, which converts to 12:35 p.m. Eastern Daylight Time. The launch is designated Starlink Group 17-38. While commercial constellations keep expanding, the Sun itself is preparing for a much larger change. The Sun undergoes a full magnetic pole reversal roughly every 11 years as part of its natural cycle. The upcoming flip will affect the structure of the heliosphere, but is not expected to disrupt life on Earth. Strong solar activity during the reversal can still produce intense geomagnetic storms, capable of damaging satellites and power grids. Observers note that widespread power outages could briefly reduce light pollution and reveal brighter auroras. The inversion occurs as part of the regular 11-year solar cycle. The Sun's magnetic field reverses direction every 11 years, a cycle whose scale is hard to picture until you map it onto something familiar. Picture a star whose surface alone spans 1.4 million kilometers, flipping its entire magnetic layout the way a handheld compass needle swings. Except this star holds 330,000 times Earth's mass, and its field lines extend past Neptune. During the reversal, the Sun's north and south magnetic poles trade places, driven by the twisting motion of plasma deep inside the star, where differential rotation winds up the field until it becomes unstable and snaps into the opposite orientation. One concrete number captures the stakes. The reversal coincides with solar maximum, when the number of sunspots can climb above 150 and the solar wind carries roughly twice the magnetic flux it does at minimum. Magnetographs track the poles migrating across the surface, and forecasters can time the flip to within months. Yet no model fully explains why the cycle length stays so steady while the strength of each reversal varies. We can watch the poles migrate using magnetographs and even predict the timing to within a few months. Yet no model fully explains why the cycle length stays so steady while the strength of each reversal varies. What hidden clock inside the Sun keeps resetting the field on such a regular timetable? As the Sun rearranges its magnetic field, another nearby star has just revealed a hidden world. The James Webb Space Telescope has identified a previously unseen planet orbiting the young star Beta Pictoris. The world appears in infrared data that penetrates the dusty debris disk surrounding the star. Its presence helps astronomers map the architecture of this nearby planetary system. Follow-up observations are planned to refine the planet's orbit and mass. The discovery was reported through the Curiosmos.com newsfeed. While telescopes hunt new worlds, a pair of space agencies are repurposing hardware for the moon. Northrop Grumman and the Canadian Space Agency are repurposing elements originally developed for NASA's Lunar Gateway Station. The hardware will now support a planned surface lunar base instead. Few technical details have been released about the new applications. The shift reflects changing priorities in NASA's lunar exploration roadmap. The report appeared first on the Space News website. From hardware plans on the moon, we zoom out to a broader look at the week's threads. The Andromeda galaxy lies 2.5 million light-years from Earth and is the nearest large spiral galaxy to the Milky Way. A recent photograph highlights its bright central bulge and sweeping spiral arms. The image was taken with standard camera equipment under dark skies. Andromeda remains a key target for studying how galaxies similar to our own evolve over time. NASA's Astronomy picture of the day for August 9 features a striking view of the Sun's surface and atmosphere. The image shows active regions, prominences, and the textured photosphere in fine detail. Daily APOD selections draw from both professional observatories and skilled amateur astrophotographers. The series continues to introduce new audiences to solar phenomena. Astronomers report a planetary mass object of roughly 0.9 Jupiter masses circling a brown dwarf that itself contains 29 Jupiter masses. No consensus yet exists on whether the companion should be classified as a planet or a moon. The detection adds to the small sample of substellar systems with known companions. Further spectroscopy may clarify formation pathways. Texas A&M researchers supported by NASA are testing how people perform everyday tasks when gravity is lowered. Early results indicate subjects adopt simpler, more economical motion strategies. The experiments use varying levels of simulated reduced gravity to mimic lunar and Martian conditions. Data will help design future habitats and tools. ESA's Hipparcos mission lifted off on August 8, 1989, to perform high-precision astrometry. A rocket engine failure left the satellite in the wrong orbit, yet operators still extracted valuable star position data. The mission pioneered space-based measurement of stellar distances and motions. Its catalog remains a foundational reference for modern astronomy. On August 9, early risers can see a slender crescent moon close to the red planet in the constellation Taurus. The pairing will be visible low in the eastern sky before sunrise. No special equipment is required for the conjunction. Observers are encouraged to watch from locations with clear eastern horizons. The moon will take a noticeable bite out of the sun for viewers in parts of the United States and Canada on August 12. The eclipse will not reach totality, but still offers a safe observing opportunity with proper filters. Maximum coverage varies by location. Organizers remind the public never to look directly at the sun without certified solar filters. Keep an eye on the next set of follow-up observations planned for the newly detected planet at Beta Pictoris. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. This show comes to you from the NARA Network. If you want another sharp daily briefing, Environmental Intelligence has you covered. The Environment and Climate Policy Brief for Canada. All our shows are free at naranetwork.com. And on the website, every episode's visuals live in our free image gallery at naranetwork.com gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.